Hello students. So today we are going to discuss the topic of motion, which is the chapter of physics of class 9. Okay. So in motion we have already discussed some topics about about distance displacement. So next we will move towards the topic of speed velocity. Clear? So distance first we will discuss some about the distance and displacement. Distance and displacement. So distance you all know. Displacement, it is the new topic for you. Okay. What is the distance? Suppose you are moving from this position to this position, from A to B. The path you have traveled from A to B. Clear? The path you have traveled from A to B is called your distance. Suppose you are from your home to school, you have traveled 10 kilometers, then 10 kilometers is the distance for you. Clear? The path you have traveled from one point to initial point to the final point is called the distance. It may be anything. Okay, if you change your position, distance means if you change your position means if you are sitting, then if you start moving, that is the change of position. Clear? If you change your position, then what is the distance you have traveled? What is the path you have traveled? That is called distance. But displacement is not like that. Displacement means suppose this is a point A, this is a point B. You have to reach from A to B. So there are different paths. Say these are the different paths. First, say by this path first you have to move from say A to X, then X to Y, then Y to Z, then Z to W, then W to U, then U to V, then V to B. Okay, suppose you have traveled here 2 kilometer, here 2 kilometer, here 5 kilometer, 6 kilometer, 7 kilometer, 3 kilometer, 4 kilometer. How much distance you have traveled? 2 plus 2 4, 5 9, 9 6 15, 15 7 22, 22 plus 3 25, 25 plus 4 29 kilometer you have traveled while moving from A to B. That is your distance. But displacement is not like that. Displacement means the shortest path from the initial point to the final point is called the displacement. Here, what is the shortest path? The shortest path will be this, directly from A to B. This is your shortest path. This path will be your displacement. Clear? Displacement is the shortest path from the initial to the final point. It is the displacement. Distance means the path you have traveled. It is a distance. Displacement is the shortest distance which you have covered from initial to the final position. When you change your state. Okay. Now, the first distance, it is the path traveled. Displacement is the shortest distance from initial to the final position or point. This is the displacement. Now, in some cases, distance and displacement may be same. Well, suppose this is the straight path. You have to move from A to B. Here, this is the only path and this is the shortest path. So, if you want to move from A to B, this is the distance you have to cover, and the shortest distance, that is displacement, you have to cover. In the straight line, the distance and displacement are always equal. Clear? Okay. Next point, it cannot be 0 or negative. So here it can be 0, positive or negative. How it is possible? Suppose you have a circular path. You have a circular path which is of radius r. This is a point A. You have to travel the whole path, means you have to travel the whole path from A to A in one complete revolution. You have to travel the complete revolution. In that case, you have to travel the circumference of the circle of the circular path. The circumference of the circular path will be your distance from A to A. So what will be the distance? It will be twice pi r, because circumference is the perimeter. Circumference of the circle is twice pi r. So for distance you have to travel twice pi r. The value you can determine by if the value of r is given. Clear? Now your displacement is 0. How it is 0? Displacement is 0. How the displacement is 0? If you have traveled lots of kilometers or meters maybe in the circular path, but your displacement is still 0. How it is possible? It is very interesting how it is possible. You have traveled from A. A is your initial path. So while moving, after moving one complete revolution, again you have reached the initial position. Again you have reached the initial position. So your initial and final position does not change. That's why you have not changed your position, so that your displacement is 0. Clear? Your displacement is 0. Now say if you are moving here, again you moved a little bit more, one complete revolution, and then this will be your negative direction. That's why displacement can be negative for some cases. Clear? And again we will see some other example of negative displacement. Say this is from O to A, it is total of 60 kilometer. Okay, say from O to B it is 20 kilometer. From B to C it is 15 kilometer. From C to A it will be 25 kilometer. Okay. Now you have to move from O to B, but your path will be, first you have to move from O to A, then you have to move from A to B. So how much distance you have covered? From O to A 60 kilometer. Again you are moving from A to B, 60 plus this will be 40. 60 plus 40, 100 kilometer. First OA, then A to B, AB. OA is 60, then it is 25, 15, 40. You moved 100 kilometer. Okay, this is your distance, but your actual displacement is this 20 kilometer. This is the shortest path between O and B. So 20 kilometer is your actual displacement. Okay, if you are moving the opposite direction of your distance, then that will be negative. Okay, same case, you want to move from O to C, but your position, the path will be from O to A, then A to C. From O to A 60, A to C 25. That is from O to C, your distance is 85 kilometers. But your displacement will be 20 plus 15, only 35 kilometers, the shortest path. So this is the difference between the distance and displacement. So we will discuss another very interesting topic. One thing, the distance is the scalar quantity. Displacement is the vector quantity. Now what are the scalar and vector quantity? Scalar quantity means those quantity which has only value, only magnitude. The scalar quantity which has only magnitude, the vector quantity which has magnitude as well as direction. So distance has magnitude only. You are moving from one point to other, that is the value. Okay, that will be your that will be your distance, and that is scalar quantity. Only it has only magnitude. But in case of displacement, in which direction you are moving, that is important. That's why since direction is included, so it is a factor quantity. Scalar means magnitude. Magnitude means numerical value. Magnitude plus, so sorry, only magnitude. In case of factor, magnitude plus direction. So that is the factor quantity. In higher classes, in class 11 science physics, you will learn about the scalar and factor quantity. Okay, just simply remind this thing. Magnitude. If a quantity has only magnitude, it is called scalar. If a quantity has magnitude along with its direction, it is factor. I will give you a small example. Suppose you know about the force. Force is the factor quantity. Why? Suppose I am pushing this wall. Okay. I am applying, say, suppose 50 Newton of force while pushing the wall. But it is very important by which direction you are pushing the wall. That is, the force includes the direction. Okay, in class 8 or 8, you have already learned that for force, direction is very important. That's why it is factor quantity. Like this, distance is scalar, but displacement is factor quantity. Okay, now remember one thing. Displacement and distance, they may be equal, but distance is always smaller than the displacement is always smaller than the distance, and maybe they are equal. So you can write displacement is smaller or equal to distance. Or if you find a ratio of the displacement and distance, it is always less than or equal to 1. Or if you write the ratio between distance and displacement, then it is always greater than or equal to 1. Okay, they may be equal. Where it is they are equal? If they are moving in a straight path, they are equal. Or if there is some short ways, then displacement and distance may be different. In that case, displacement is smaller as compared to the distance. Or in straight path, both of them are equal. So this is the numerical formula for the distance and displacement. Okay, so in the next class, we will discuss about the speed and velocity, difference between the speed and velocity. And we will discuss graphical representation, which is very important. Graphical representation in the next class we will discuss. Graphical representation means if you cover a distance with respect to time, what is the change of the distance? Clear? If a person or an object is at rest, then its distance does not change, only time is changing. Okay? In that case, the graph will be, suppose this is the graph. Time axis, you have two axes, time axis and distance axis. Distance, or it may be displacement. Okay. So if a person is sitting here, if the person is at rest, rest means stationary, so the graph will be like this. Why? Because with changing of time, time is changing. At every moment time is changing, but he is at rest, means his distance is not changing. So it is a straight line which is parallel to the x-axis or time axis. And one thing, stationary, rest means what? Rest or motion. Rest is if an object does not change its position, then it is called rest, or stationary you can also say. If an object does not change its position, then it is called rest or stationary. Or if an object or person change its state, then it is called in motion. Clear? But the thing is, an object may be at rest or at motion for some different objects. Suppose we are at rest. If you are sitting in your room, then you are at rest. But in comparison to the other planets, the Earth is always moving, na? So you are moving along with the movement of the Earth. Clear? And our natural phenomena like day and night, okay, the changing of seasons, they are all due to the motion of the earth. Clear? And one thing, the rest or the motion. Suppose you are moving by a bus. You are sitting inside a bus and bus is moving. When you observe the surroundings through the windows of the buses or cars, then it looks like the other things are moving backwards. You are moving to the front and other things are moving backwards. It means that those objects are in the outside of the bus are moving as in terms of u, but they are actually at rest. So the definition of rest and motion is different for the different observers. Clear? So in the next topic we will discuss about the speed and velocity and about the rest motion graphs, different types of graphs. Thank you.